Day 648 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. In the day, we have question number 3719, longest balanced subarray 1. The difficulty level is medium, so you already know we're going to keep the solution as simple and easy to understand as possible, though. So before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given an integer array nums. A subarray is called balanced if the number of distinct even numbers in the subarray is equal to the number of distinct odd numbers. Return the length of the longest balanced subarray. All right, y'all, so that sounds simple enough, but before we get into these examples, let's go over what the definition of a subarray is. It says a subarray is a contiguous, non-empty sequence of elements within an array. So all that means is we want to create an array inside of the input array and see what is the longest array that we can create where that array, that new subarray that we create, is balanced. Boom. So in example 1, we have our input nums equals an array of integers 2, 5, 4, and 3. Then the output is 4 because we're not returning the balanced subarray itself. We're returning the count or the length of the longest balanced subarray. In this case, it's 4. Explanation says the longest balanced subarray is 2, 5, 4, 3, which is what we started with. It says it has two distinct even numbers and two distinct odd numbers. Thus, the answer is 4. So we have two distinct even numbers, 2 and 4, and we have two distinct odd numbers, 5 and 3. So that means it's balanced and it has a count of 4 or a length of 4. Boom. Now, just in case that didn't make sense, let's take a look at example 2. So in example 2, we have our input nums equals an array of integers 3, 2, 2, 5, and 4. This time the output is 5. Explanation says the longest balanced subarray is 3, 2, 2, 5, and 4. It says it has two distinct even numbers, 2 and 4, and two distinct odd numbers, 3 and 5. Thus, the answer is 5. So in this example, it breaks down how we want distinct even and distinct odd, right? Meaning we're only counting the number once. So even though there's two 2s in this array, we're only going to include or count once when we are deciding whether it's balanced or not, right? So the distinct integers would be 2, 3, 4, and 5. These are all of the numbers that occur in this array, right? So distinct means we just want the number itself. We don't care how many times that number appears. We just want to know what numbers are in the array. So it has two distinct even numbers, right? The only even numbers in this array, we can look at this array. The only even numbers in this array right here are 2 and 4. Even though there's two 2s, that's still the same number, so we're only going to count it once. That's what that distinct means. So it's only a 2 and a 4, and it's only a 3 and a 5. Those are the only integers that exist in this array. It's 2, 3, 4, and 5, right? So we're only going to count this 2 once, even though it appears twice. So 2 and 4, that is two distinct evens. Then we have 3 and 5. That's two distinct odds. That makes it balanced. But we include the whole subarray, right? So the whole subarray right here has two distinct evens and two distinct odds. So we return the length of this entire subarray, which would be 5. Boom. So just in case that didn't make sense, let's take a look at example 3. So in example 3, our input nums equals an array of integers 1, 2, 3, and 2. This time the output is 3. It says the longest balanced subarray is 2, 3, 2. It has one distinct even number 2 and one distinct odd number 3. Thus the answer is 3. Boom. So right here, this is the longest distinct, this is the longest balanced subarray right here. Now, say we did this, right? You might say these numbers are distinct. This has all distinct numbers. However, it does have all distinct numbers, but it's not balanced because this 1 and this 3, there's two odds. But if we did this, then there's only one even, which would be this 2. Now, if we do this, right, or say we do this, there's one odd and one even, right? but we want the longest balanced subarray that we can create. So there's a subarray that's longer than this that still fits the requirements, right? So this subarray right here has a count of 3, which means it's longer and it still fits the requirements, because even though there's 2 2s, it doesn't matter because they're the same. So we're only counting 1 when we're deciding whether this subarray is balanced. So there's only one even number. That one even number is 2. There are no other even numbers in this array except for 2. So it has one even number, and then 3 is that one odd number that we're looking for that makes this balanced. Then once it's balanced, we return the length, and it has a length of 1, 2, 3. So that's why our output is 3. So boom, y'all. I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Solution's not that difficult. Now, the first thing we want to do is we want to store the maximum length of a balanced subarray found so far. So we can just come right here, declare a variable called res, and we'll set that equal to 0 just to start. Now we're going to loop through and choose the starting index of the subarray. So we're going to come right here and say for I in 0 dot less than nums dot count. Boom. We're going to open up the brackets, and we're going to use a dictionary to count the occurrences of the odd numbers in the current subarray. So we're going to declare a variable called odds, and we'll set that equal to a dictionary of integers, colon, int. Come outside of that, and we are going to put the parentheses. Boom. Then we're going to create another dictionary to count the evens. So we're going to declare a variable called evens, set that equal to a dictionary of integers as well. Boom. So the key is an integer and the value is an integer. Boom. Now we're going to loop again to extend the subarray from I to j. So we're going to say for j in I dot less than nums dot count. Then we're going to open up the brackets, and we're going to check if the current number is odd using a bitwise AND. So we're just going to say if nums square bracket j, come outside of that, and that's the bitwise AND, 1 equals 1. We're going to open up the brackets. We're going to increment the odd count for this number. So we're going to say odd square bracket nums square bracket j. We're going to say comma right here, still inside the outer square brackets, because this is where we're going to increment our dictionary. So odd nums j, boom, comma, default, colon 0. Then we could come outside of this square bracket and say plus equals 1. Boom. Then we come right here, and we can say else. We'll open up the brackets, and we're going to increment the count if it's an even number. So we'll say evens, square bracket nums, square bracket j, come outside of that, comma, default, colon 0. Then once again, we'll come outside of this, say plus equals 1. Boom. Now, if the number of distinct odd values equals the number of distinct even values, then the subarray I through j is considered balanced. So we could come right here underneath this if, and we're going to say if odds.count equals evens.count. We're going to open up the bracket, and we're going to update the result with the length of the current subarray by saying res equals max, open up the parentheses, res, comma, j minus I plus 1. Boom. Then we're going to return the length of the longest balanced subarray by coming right here, and we can say return res, y'all. Boom. That's all she wrote. Let's give it a run. Make sure it runs properly. Okay, so let's see what we got going on here. Oh, this should be odds with an S, not just odd. So now let's run it, see if that did the trick. Okay, now let's see what happened. One moment, y'all. Spelled it wrong. Okay, so let's do it like this. That's incorrect argument. Boom, now let's run it. Let's see, that did the trick. It's accepted. So now let's go ahead and submit it and make sure it's still accepted after we submit it. Let's see. And look at that, y'all. 573 milliseconds beats dash percent of users. Not bad at all, y'all. So, with that being said, make sure you get one more look at the code. This is the top. This is the bottom. And yeah, y'all, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.